Hello. In today's video, we will be discussing how we can use property analysis to determine if a chemical reaction has taken place. So, as we remember, chemical reactions take place when one or more substance turns into an entirely new substance. We know that this happens through the breaking of chemical bonds, the rearranging of atoms, and the formation of new substances with completely different identities than the original substances. We also know that there is some evidence or signs that tell us it's very likely that a chemical reaction has taken place. Things like color change, temperature change, the formation of a gas, a precipitate, or the production of an odor. However, we also know that these are simply signs that tell us it is likely that a chemical reaction has taken place. They are not enough to prove whether or not the reaction has occurred. In order to do that, we must perform property analysis. As a quick reminder, we know the properties of matter are characteristics of pure substances. We know that every pure substance has its own unique set of properties that can be used to identify it, just like a person's fingerprint. Recall that substances with the same set of properties means they are the same substance. Their fingerprint or their properties is the same. However, if I look at substances and find that they have a different set of properties, this tells me they are not the same, they are different substances. Now, in order to determine if a chemical reaction has taken place when multiple substances interact, we must analyze the properties of those substances. In order to determine if a chemical reaction has taken place using property analysis, we need to look at the substances before they interact and then after those substances interact. There are only two options that we can find here. First, we may discover that the properties of the substances after the interaction has occurred are the same. This tells me their properties are the same, that the substances are still the same substance, meaning that no new substance has been formed and hence no chemical reaction has taken place. On the other hand, I could also find that the properties of the substances after the reaction have changed or are different after those substances interacted. This tells me that the properties are different, meaning the substances are different and a chemical reaction has taken place. Now that we know how we can determine and prove if a chemical reaction has taken place, let's look at an example of analyzing properties before and after an interaction to determine if a chemical reaction has occurred. So here we have two different substances with some information about their properties before and after those substances have interacted. We see that we have information about the boiling point, the melting point, the density, and the flammability. A quick check over of these substances comparing before they've interacted to after they've interacted shows me that there has been a change in many of the properties of these substances. I can see that their boiling points have changed, their melting points have changed, their density have changed, and in one example, the flammability has changed. This tells me definitively that a change in one or more property has taken place. This means that these substances after the reaction or after the interaction has taken place are no longer the same substance. That means that a chemical reaction has occurred. In this example, we're actually looking at the reaction between methane and oxygen. Substance 1 and 2 before the substances interacted were indeed methane and oxygen. Afterwards, we can see that we no longer have methane and oxygen. We now have carbon dioxide and water, which is why we see a difference in properties and which is how we know that a chemical reaction has indeed taken place based on analysis of this data. Let's look at one more example here, and I'll allow you to do the analysis on your own. Here we see that we have a single substance before the interaction, and after this interaction, we see two different substances. We also have information about the boiling point, melting point, density, and flammability. So remember what we've just discussed to take a look at this and analyze to determine whether or not this is an example of a chemical reaction or just two substances interacting with one another. But wait, there's more. This is indeed the data that we have collected from our surveillance video of our unknown reaction in vial 3. You can now use this information to begin your property analysis to determine which of the president's antidotes is still safe and can save the president's life?